Here's the contactor, transformer, capacitor. Can't find the relay right now. Relay looks like it's a square thing, but it's employed as it's like a contactor basically.
It's like on the board, the little relays
Oh,
on the board.
no, it's on the board. Yeah. Well, we can. Yeah.
Yeah, all these clicking, click, click, click.
So we have wire cables, high voltage cable going to the contactor. Okay. We have 115 and 115. Right now we're gonna run high voltage wire through the system, okay? Now, high voltage we're gonna throw to compressor. We have to start the compressor, right? We have to apply 240 to compressor. So we're gonna dedicate one of these poles, we're gonna call this pole 1, pole 2, okay? So one of those poles we're gonna dedicate to comma, C. On a compressor you will see one plug C, another plug
S.
no, run and S, or opposite, you know. So one we're gonna do, let's say it's this, we're gonna dedicate to comma, to C, okay? We need capacitor here, capacitor here, capacitor over here. Now we have to run the opposite pole to run and start. You can do, but the start goes through the capacitor, okay, like this. You can do, you see capacitor has also two plugs, okay? So you can run, connect one plug, and from this plug you can connect straight to the R, run, or you can throw, straight over here.
So on the same prong, you're gonna have two different plugs. So one with power,
Yeah.
and one to the run.
Yeah.
Okay.
Now, from here, so we apply already two connections, right? C and R, run. Now we need start. Start goes over here, like this. From capacitor, the other plug, the connector, to the S, to the start. So S start, R run.
This is a dual, right? A dual cap.
No, this is not dual. This is
Starting.
capacitor. It's a regular capacitor. It's not dual capacitor. It's just
all
regular
capacitors,
capacitor.
yeah. They all have this.
The dual,
Some have three.
the dual, it's you will see three.
Three?
Which is
Okay.
a dual. It's combined a big capacitor for compressor and a small capacitor for motor.
Okay.
Yeah, it says right there, like the
Yeah.
MFDs.
Okay.
Right now, I'm just running the simple
Yeah.
diagram. So we apply high voltage to the compressor, okay? So once you activate the contactor, 240 volts gonna flow straight to the compressor through the capacitor, okay? So capacitor start compressor and R will run the compressor.
And the 115 is coming from the thermostat?
Hold
Oh,
on.
sorry. Yeah.
Thermostat and transformer, that's for low voltage.
Okay.
We're not
Not there yet,
Right,
gotcha.
right now, yeah, we're
right.
we're connecting high voltage. So okay, we connect the compressor. Now we have to connect the condenser motor. Condenser motor, it's a simple. Again, we have one connection, one wire, which goes to, let's say it's not, okay, comma we throw, one wire, another over here. So we're supplying 240 volts to the motor.
Directly, not through the capacitor?
Directly to
Okay.
the motor. The capacitor you connect to the motor. It's two dedicated wires going to. There is variety of motors that there is schematics. If it's not, it's like a bunch of wires, and you have to read the wiring, which wire goes to what. But usually you're gonna have regular motor with two wires for the power and two wires for the another two wires I'll show you for reversing the polarity.
Yeah, they have like 4 wires and stuff.
It's like I remember it's kind of coming back a little bit here and there.
The condenser has its own power supply. Close to
Yeah, here is the condenser motor. Brown wires, that's a capacitor.
Okay.
This is power.
Okay.
It doesn't really matter how you're gonna, it's just, same 151. And this is polarity. It's can turn this way or this way.
Okay. And you need to switch them? Switch them either
Yeah,
way?
you never know.
To pull or
you,
to
you
blow.
never know, so you basically, install the motor, put the fan, start, and see if the fan turns right way. Okay, if not, just stop.
If you get air in the top,
Disconnect.
you're good.
Yeah.
If
It
you're
needs to
not
blow
getting
out.
air,
Yeah, it
Yeah, but sometimes no. You look at the.
You know why those wires you can switch them around, right?
I don't know what the point. Why would you need them? If it was supposed to go one way, what's the point of having
The
them the other way?
poles, the way the power flows through it. You know how AC runs, right?
I'm sorry?
AC?
Yeah?
House, how the power runs? It goes back and forth.
Yeah.
And then DC is like just one way. That's why it's
Okay, there's different condenser units. Yeah, newer ones, the air goes up. There is some condenser units or package unit when it's gonna blow inside. So you go by the blade, okay? The blade supposed to turn. It's supposed to grab the air. Okay, so which way do you think this blade goes?
right now, or how it's supposed to go?
How it's supposed to go?
So if it's going this way?
No.
No, other way around. Instead of 50.
No, look, this this way it's gonna grab air, right, and push down.
Oh, I see what you're saying.
If it turns this way, it's actually
If it's upside down, right?
no. Yeah, it's gonna be
Yeah,
upside,
upside
down.
down, yeah.
So, but again, I'm telling you,
Yeah. Okay.
it could be upside down or up.
Gotcha.
So that's why you have to see which the actual blade, the structure of the blade,
Okay.
and you go by the blade. Do you understand?
Yeah,
right?
that makes
You
sense.
see, this way it grabs the air,
Grabs the air, and that way it
so
pushes
it pushes down.
Okay.
This way
Pushes
it
out.
Pushes out.
it. Okay, that makes sense.
So yeah, when you disconnect wires like anything, man, you don't want to go through the schematic and all that stuff. Just label that shit. You know what I mean?
Yeah.
It's a nightmare sometimes. Shit comes off and you're 120 degrees outside and you're trying to figure shit out. There's wired up, especially in the attic.
I've replaced one of those for my aunt one time. Whole thing came apart, came loose and part the blade and everything.
Yeah.
That sucked. The inside of it came loose.
Yeah.
That was enough fun repair.
Okay, so we connect condenser motor. So contactor activates and supplies voltage to the compressor and the condenser motor. So we have compressor and the motor up and working. Now we need blower working, right? It's supposed to blow the air. We have okay, capacitor. It's capacitor. Now, one leg.
Is that thing on the left the?
We have to make sure we will able to turn on and off blower motor. Okay. What turns on and off the blower motor?
The thermostat?
Thermostat controls the whole unit.
Oh, what, directly? Then I'm not too sure.
The board,
Board
green.
or relay. This is regular relay. That's how it looks, regular relay. This is time delay relay.
Whoa.
Okay? Time delay relay usually you install on a heating mode. This is regular relay. Relay works exactly like contactor, but it controls one pole. Contactor controls both poles.
Oh, so there's one small pole inside there?
No. What I'm saying is, this breaks
Yeah.
two poles
Uh-huh.
simultaneously. A relay controls only one pole.
So it's like a switch, just off and on?
So basically, the relay is this,
Yeah.
is that,
Got it.
and then this guy needs
Has
all,
two separate ones.
but they're both going to the compressor.
Uh-huh.
So you have direct power because you need all the amperage going to this stuff. You see that? It's higher amperage.
Mm-hmm.
This is like lower amperage, so it only needs the one little hole.
Okay. Gotcha.
So you gotta imagine just inside of that thing.
That one little thing in there. Okay. And it just clicks off and on?
Yep.
Yeah, well, we'll go with
Okay.
But you will see contactors looks like this, but one pole it's straight, so it will control only one pole. But there's two wires going through.
So basically, it's the same thing, but one straight wire and then the
Yeah,
other one just.
one straight and breaks only one.
Okay. That makes sense. Now, how does that switch get activated? From the board? Oh, there we go. Now we're getting into that.
We're going there.
Yes.
First, the high voltage. Okay, so one line, let's say it's this one, goes through relay. This is relay. Here. Okay? From relay, it goes straight to the motor. Another pole goes straight to the motor.
Oh, okay.
That's how we supply 240 to the blower motor. You see, we throw 240 volts throughout the unit. So right now we're talking about package unit. Because if it's a split system, then it's going to be 115 on this side,
So the
on the
blower
blower side,
115?
and 240 on the condenser side.
Okay, but if it's a package, it's
If
240.
it's packaged, it's all 240.
Okay.
Okay, so now we connected blower and compressor and motor. Now we have transformer. What transformer does? What
Goes through. It just goes from like 24 to 240 or whatever. The low voltage to high voltage.
high voltage
transfer.
to low voltage?
Low voltage. Yeah.
And it powers this.
It basically will power contactor, relays, all components that needs 24 volts. Okay, or control board.
T-stat.
Isn't that right off the thermostat as well?
This is not thermostat.
I'm just pointing at thermostat.
The
But right
no,
at the thermostat.
thermostat. Okay, hold on. Let's connect transformer for now. Okay, so we have one pole and another pole. So we supply 240 volts to the transformer. Now we need 24 volts. Make sure it's going through the system. Now we're going to discuss the thermostat. What actually thermostat does? What thermostat is? What is for?
To control the system's temperature, pretty much.
Right, but what is it employed for? What is actual?
Turns on the heater, the
Okay, thermostat, it's a regular fucking switch.
switch, yeah.
It's a switch.
Tells everybody what to do.
It just turns it off and on.
It's a turns on and off. Okay, there's manual thermostats and there's digital thermostats. It's just manually you have to set, you have to do everything manually. Digital it's on batteries or internal source 24 volts.
Hardwired into
Hardwired.
Oh,
Yeah.
okay.
So we have R, C, G. Let's pretend this is yellow. And W.
Give it more color.
Okay, we're not gonna do anything with W right now. W is for heat. Okay. So we have R, G, W, Y, W, and C. Transformer will generate 24 volts, two wires. One, we're gonna dedicate as a comma. We'll decide, okay, one side as a comma. Another side is R. It's a red. That's why, you know, when you open the unit, most of the time you see red wire. I'm talking about low voltage, red wire. It's 24 volts live, and a blue or black will be common. Okay. So now we're gonna connect common to all components we have. We have contactor and we have relay. So one goes to contactor, one to relay. Now R going to thermostat, and from the thermostat this R will distribute to the other components. If you put thermostat on cool, that's mean you connecting R with yellow and a green. Now green, it's a blower. Okay.
What do you mean by connecting R with G and Y?
Internally,
Internally?
if you put switch, so you set thermostat on cool. Internally, it will jump
Oh, jump both of those out.
R with the G and the yellow.
Okay.
Okay.
So even if you take you disconnected those 3 wires from the thermostat and you put them all with the wire nut,
Yes.
it sure kicks on the cooling system
Okay.
to check the
Check everything out. I think I remember that. Yeah, I think I
So
remember
we just wired blower, and by turning on the thermostat on the cool, the blower right now is on. It's working. Now we have to activate the compressor, and compressor activates contactor.
the
activates
contactor?
compressor. That's it.
And now it's on. It'd be running right now.
If you switch the,
Yes.
if you turn on the
On the
thermostat,
thermostat.
on the cool, all these 3 connected together, and you have 24 volts flowing to the contactor and to the relay. Unit is on. Any questions?
Makes sense. I remember this a little bit from school. Yeah, I
Okay.
remember doing this in school.
It's a basic wiring.
Yes.
But on the field, you will see different wirings as far as
different colors and
different colors. Let's say compressor can be wired. Not this compressor wire. It's not gonna go. Let's say it's go through the capacitor. It might go straight to the. It can. The 2 wires can distribute straight from here. One here, one there. Not through the capacitor. It's just variety of, you have to see that on,
Yeah.
in the field.
on the field. You can't really,
There's different varieties for everything.
Yeah, but always you have to go to the if you don't understand something, what's going, just go back to the basics.
Low voltage.
Sometimes if there's a bunch of wires, it's old system, been worked on many times, and everybody connects, and you don't know what the fuck is going on. You just physically have to trace each wire where it's going. But you have to see that all those components and wiring in your brain. That's what makes
Easier.
no, the technicians apart. One technician can work, or he see what he sees in front of him. you know, let's say, yeah, he can trace the voltage and stuff. Oh, capacitor is bad. Okay, he replaced capacitor. But if it's more complex, like wires goes everywhere and components, you have to look for components, his brain goes nuts. And he gives up, right? You know, right there. Oh, I don't know what the fuck is going on here. And its ability of brain to actually compose and just go to the basics. The basics are conductor, compressor, capacitor, motor, relay, transformer, thermostat. That's, if you have to, you just have to, rewire everything. And that's what happens once in a while.
That's if a customer's trying to do their own fix and they mess up everything.
Rarely happen, but most of the time it's technicians who does their own stuff,
They won't mess up, huh?
And I see all kind of stuff. I see genius stuff, man, out there. I'm telling you, genius. I saw once, I don't know if you heard or not, but blower motors, right? Those new multi-speed variety motors.
VFCs?
No, I don't know how they call them, but it's a board attached to that, manifold attached.
Oh, a digital one, yeah. The digital motors, they start slow and then they build up speed.
No, not those. No. Variable speed motors. It controls those motors controls by the board. It's not just 2 wires going. It's like 10 wires, and it changes speed, because it's like 14, 16 SEER unit, and the speed of the motor has to match temperature of the freon, all kind of shit.
Mm-hmm.
And you can't really troubleshoot this shit, man. To troubleshoot motors like that, you have to know that not just diagram. Probably you have to call support, the manufacturer, and they will tell you, okay, look, check 24 volts here, 24 volts. It's fucking complicated. Yeah, it's not like, okay, you have 200 volts going to the motor or not. No, it's just really complicated. So I saw one guy, he rewired that motor, and he threw the transformer and just put two wires, regular wires, 240 volts, but because there's 24 volts that controls the speed inside, he just supplied through the transformer, not through the board.
Directly to it?
Yeah, you don't really. And this shit works. And it was working, man. Do you understand?
Yeah.
So there was some connection, bad connection between board and the motor. He rewires the whole fucking shit.
To work, yeah.
And it was working. I think, whoa, man.
Yeah. How do the boards work into all this? Is that something we'll get into later in the diagram? Because the boards is where you're confused.
Board. Okay, this is for gas split system. You see this connection from the thermostat?
Thermostat?
Yeah, thermostat connection. This is relays that controls the blower and inducer motor. Because inducer motor, that's on the heating side. Also turns on and off by the relay. So you connect the blower motor
Like how it works or how it's connected, or what do you mean?
How does it work inside of that system? Would it
here.
be in
Cool. You see, you connect blower one wire. One wire. Usually it's a black wire. Goes to the cool. And heat, it's gonna be probably red or blue. And the white, it's a comma.
Common.
Goes on the neutral. In the neutral over here. Comma. I think neutral is over here. Okay, and then those relays turn on a cool side blower or on a heat side blower. Okay, and on the heat side, why it's a separate, why different plug? Because on the heat side, it always have to be with the time delay.
So does this supplement some of these parts up here, so you wouldn't have those parts?
Yeah, I
Okay.
put, let's say, this goes instead of this,
Oh, okay.
basically, you know.
Okay.
But on the cool side, you know, that's the only thing it controls.
It's just the blower?
Just contactor and the blower motor. On the heat side, there is more to it.
Oh, okay.
On the heat side, you have limit switches. There is, you know, inducer motor, gas valve, and it goes all through here.
That makes sense. Okay.
Again, you can do all just regular relays. You can wire as a regular relays.
Oh, just instead
Yeah,
of this?
you can illuminate all this.
Yeah.
Yeah, so pretty much like these ones. All these right here.
Yeah. Okay.
You have like 3 or 4 of these doing stuff.
So it just has a kind of small compact instead of kind of spread out. Is that the benefit of having a board?
You will see old units. Will see only relays,
Yeah. All over the place. Okay.
It's like modern. Right?
and you see, yeah, or you see just board.
Okay.
As far as the blower and the blower wheel, again, which way the wheel supposed to which way wheel supposed to turn? Who can tell me? By looking at the wheel.
Is it pulling this way? Through here? Is it
Doesn't
pulling
matter.
odd not to-
You just look at the wheel.
Oh, right here from the wheel?
Yeah.
If it goes this way, it's pushing. If it's going this way, it's pulling.
Which way it's grabbing the air? This way or this way?
This way? Because it's going down through here? It pulls
Yes.
the air down.
Yeah.
Yeah.
Yeah, you see?
Yep.
Yeah, this way it grabs the air.
Yeah.
This way it pushes the
Yeah.
air.
That makes sense.
That's the way it's supposed to run. Again, when you replace the motor
Your hand spin, you can feel it.
and you know you don't really know, you have to start and see which way it's going. Then you switch polarity if you have to. Okay, we're done with wiring today. Okay,